I'm asking pulley. All pulleys are light, strings are inextensible and they're light. I'll release it. You have to find out the acceleration of the pulley P. So let's come for the tension, showing the forces. So first weight M1G will act. There's a tension. There's a tension. And how much here tension will be? 2T. And the weight M2G will act here.
Sir, on M2, one of the force will be 2T, sir.
Ah,
About
2T, no. It's
total
a
will
bit like
be
this.
3T.
Sir,
Ah.
on pulley there will be unbalanced force, right, sir?
Yeah, that's what the question, the situation has come like this.
On T by 2 now.
What is this? What is the thing like this? So yeah, different students are giving different answers, no? Different students are giving different answers. So then who is right here? Yeah, fine. I think
So shouldn't that be T by 2?
Different set of students are giving different answers. So definitely then to whom I should support. Almost everyone started giving different answers. I think everything information is there. So definitely what I shown here, you may object, no? Sir, what is this? Like, how can you write here? This is T, that one. So if another student, what you'll do is like, you'll begin the same concept like this. Huh? Another student, the same diagram, you will start tension here, T, T, this will be T, you'll get some other thing. So altogether, look at the tension on the pulley, that one. If you assume this T, here you'll get T by 2. Here if you assume this T, anything, either way you can proceed, no? If you assume this T, here you will write T by 2, T by 2. So then what is the problem here? The tension on that sort of pulley will be different, no? So some students, what happen? I'll show other way also. There's a very random thinking. So that really, it troubles a lot. Let me draw one more similar diagram. Yeah, here I think you are. Okay, the other student, what happened? He will not draw diagrams like he will not assume the tensions which. So other student, open he may go like this, no? The tensions. You see that really. So here, what I do is like, here if tension T by 2, T by 2. Okay, can I begin like this also? T by 2, T by 2. Here T by 2. This will be how much? T by 2, T by 2. And here this will be T and this is T. Tell me who is right here? Got the idea, all of you? So nothing wrong, no? So what is the wrong with the first student, second student? Both are fine. Both are very good in their physics and both they are shown like this. So there's some problem is there. So look at the pulley. Pulley P is light, no? And what is the net force on it? Is non-zero here. The net force in the first diagram. Come for here. We know the tension on either side of pulley should be same because pulley is light. This is light or massless. Then the tension on the either side of pulley should be same, T and T by 2. So, but it is becoming T and T by 2. It should be T, T or T by 2, T by 2. But such a thing is not happening here. So, or what happened? What I should do is like, I should adjust for this as this is suspended, no? So here I'll bring it like this. This should be the distribution. Okay, now look at all together, look at the pulley P only. What was the force acting downward? T by 2, T by 2. Upward is T by 2. If you look at this diagram, you're getting T upward to T downward. Okay, got this? So the tension on the either side of suspended pulley should be same. But here this pulley P is a problem, no? Fine, I think some of you did this, some of you did this. Tell me like who is right? Both are
Sir,
right. Huh?
string will be broken, sir.
Nothing. So nobody please don't any suggestion. Let me listen for teacher. So in both the students are correct here, no? Both the students are correct. So what actually happens is like here the net force on the pulley should be 0. So I'll write the equations. You see mathematics. I'll write the equation now. 2T minus T equal to mass of pulley into acceleration of pulley. Fine. This is. So now here what should happen that one? The tension, can it happen? What is mass of the pulley? Mass of pulley is 0 as it is light. If so, therefore this will be 0 into AP. But acceleration of pulley will be non-zero. So therefore, what should happen now? Tension will become 0 from the mathematics. Tension 0 means here, what is the state of the blocks? They'll have free fall. So now I'll write the constraint equation. So there's a reference point. There's a reference point, the pulley P. Then for the block M1. Then next movable pulley. Okay, this one. So let's write constraint equation. Let's see that. So this should be the XP. This should be the X1. This should be the X2. Any constraint equation can you write? for the length of the rope? X1 minus XP. What can be this distance? X2 minus XP. What is the distance? X2. And what is this? XP. So let's write the constraint equation now. X1 bar minus XP bar plus X2 bar minus XP bar plus X2. Then minus plus XP. Try to see the constraint equation should be equal to this much. So therefore this will become A1 plus 2A2 plus AP bar equal to 0.
Sir, minus
Sir, minus
AP.
AP.
Sir, minus 2 AP. 2 AP.
Minus AP only. Huh?
Sir, 2 AP.
One plus XP,
Yes,
minus
sir.
XP, minus XP. So I got finally this particular thing. Look at the tension 0. If tension 0 means what happened to blocks? As tension 0, as T0, blocks will have free fall. Blocks will have free fall motion. So therefore, what should be the acceleration A1 equal to G downward? A2 should be equal to G downward. So substituting that, G plus 2G should be equal to AP. So what is the acceleration of pulley? 3G downward. Practically not possible. It's on paper because we can never get massless pulley. We'll never get massless string. Inextensible, okay, I'll get it. So Smith sir, when to think like this? Whenever the net force on the pulley, if it is non-zero, then what happen? The string, what happen, will become loose, then what when the blocks will have free fall, and any pulley acceleration that you should find out with the help of constraint equation. Both are right. Both the diagrams are right. So here what will happen to the string? String will become loose. Net force on the pulley should be 0, no? Net force on pulley should be 0. So therefore T will become 0. Both are correct. Nothing wrong. So how do I come to know that the blocks will have free fall? What you should do? Not this pulley. Don't bother this pulley. Yeah? Don't bother this pulley. Don't bother this pulley. You should not bother this pulley. You should look at the intermediate pulley like this, of this kind. Or even this also, because the mobile pulleys only you have to take care of that one. The fixed pulley, don't bother. On the fixed pulley, the tension on either part of the rope should be same. So what you should do now, whenever you get a blocks and a pulley, and where all mobile pulleys are there, you have to check once, is it more on a mobile pulley, net force 0 or non-zero? If it is non-zero, then the string will become loose, then the blocks will have free fall, then the acceleration of that mobile pulley, we should find out with the help of the constraint equation. Got the idea?
Yes, sir.
The concept, this way what happened, it has to be analyzed here. Practically, the situation not possible because we never get massless objects. This is on paper. So therefore it's of no use for any application. In books one year and there it has come. So don't feel something, this is very important here. I feel like just not worth spending more time. Just have a basic idea. So when the blocks will have free fall, when the net force on the pulley is non-zero. Provided all the pulleys are massless. If pulley is having a mass, then what happens? The net force on it can be non-zero. Am I right? Again, don't take it another way. If pulley is having a mass, then this question is correct. We can solve it. Are you able to understand? So pulley is massless, this situation will come. Okay, no, I'll upload everything. Okay, that one. You revise for exams. Huh? Okay, thank you, all of you.
Thank you, sir.
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 Sir.
Okay, thank you, all of you. Take care. Bye. See you.